by Andreescu's number theory book. Now let's go ahead and jump into it here. This very first fact is pretty crucial, since x can either be an even number. We'll just say x2k, x is equal to 2k, k an integer. All right, that's a possibility. And if you square x, you see where the 16 comes from, right? Okay, and m would be k squared. Now, in a similar fashion, I think this might be a little harder to prove. I think it's just a binomial theorem. If x can either equal to 2k or 2k plus 1, right? Even and odd numbers partition the integers. A number is either even or odd, right? So this fact right here, this statement right here, motivates us to take this number. And again, what are we trying to do? We're trying to write this number 3512 is the sum of n fourth powers. Okay, is the sum of n fourth powers, and we're looking for the smallest n that gets the job done. Okay, and again, this was motivated by a problem in Tiddu, a very prolific number theorist textbook. All right, now now you can see right here this fact that everything that fourth powers can or in 16, that relationship motivates us to divide by 16. Okay, and this is what happens when you divide 3512 by 16. You get 16 times 219 plus 8. All right, now this is probably not the most rigorous statement here, but you have to consider the cases where the 16 m's pair up with 1, right? And 8 is the same as 8 ones, right? 8 is 8 ones. Need I write it down? 8 is 8 ones, and so each of those 8 ones can pair up in this fashion. Okay, so that's why I claim that n has to be greater than or equal to 8. All right, now I know that's not super rigorous, but it sounds convincing enough for me. All right, now so let's continue. Now, each of these m sub i's, okay, have to sum up to the 219. That's clear because this is 16 times m sub I, right? But 3512 puts some constraints on the upper bounds for the m sub i's. And I don't think that requires a whole lot of explaining. Summation I equals 1 to 8 of m sub I has to equal to 219. And anything that would exceed that would be taboo here, okay? So let's keep going. Now, another way to rewrite this statement and get it in terms of the constants m sub I so we can establish some bounding here is this way, okay? And this is just some basic algebra. Subtract 1, divide by 16, and you get m sub I is equal to x sub I to the fourth minus 1 over 16, all right? And the only way remember, these are natural numbers, right? M sub I, they're natural numbers. Let me put a member of the positive integers. I'll put z plus if you want, rather than the natural numbers. Positive integers. Okay. The only way this part can be an integer is if the x sub i's are odd. If you square an odd number, you get an odd number back. If you subtract 1 from an odd number, you get an even number. Hence, the divisibility would be possible right here. Okay. So these are the x sub i's we have to consider. 1, 3, 5, 7, 9, all the way out to 15. All right. Now, the next part here, the next part is just some number crunching. And I guess we should call this m sub 5 right here. Probably not that it's that big a deal, because that would be the 5th term in the list above, right? So this would be your m sub 5. If you consider 9 as the 5th element in this list of 8. 9 is the 5th element in this list of 8. So we get 410, but notice just that term alone would be bigger than the 219. Right. 410 just all by itself, m sub 5 would be equal to 410. And so there's no way you're going to get a summation going on here where the m sub I is equal to 219, right? And so what that does, that the possibilities would be everything less than 9. You see this 9 here? All right. Certainly it would be bigger for all the other numbers past 9, right? Okay, so we can only consider 1, 3, 5, and 7 as our x sub i's. All right. So let's go down now. Y'all, the rest of this is just some computations, and I left out some of the tedious aspects of the computations. But I did discover that 7 raised to the fourth plus 5 raised to the fourth plus 6 copies of 3 to the fourth does sum up to 3512. Pretty cool. I liked it a lot. I'm excited about it. Now, you may be saying, well, you didn't really prove that n was equal to 8. N equals 8 is the smallest, but I don't see how you could get even numbers, fewer even numbers to add up to 3512 because you have to account for the 8 remainder, right? So this is the n equals 8 case. Notice there are 1, 2, 3, 4, 5, 6, 7, 8 fourth powers that do sum to 3512. And that does take a little bit of time to do the computation, but that solves that problem. I hope you enjoyed. And I think there's a lot more open questions associated with this type of problem. Go Djokovic.